Right now, this very weekend, the strongest heat dome anywhere on the entire planet is sitting directly over the southern United States. Temperature records are expected to fall across 19 separate states, with extreme heat and dangerous humidity forecast to linger well into next week. And here is what should genuinely concern you. This is not the first heat dome of the summer. It is not even the second or the third. This is the fourth major heat dome to form, stall, and break records in the span of roughly a single month. And scientists studying exactly why say the position of the jet stream driving all of this has no real comparison in the historical record. To understand why that matters, you first need to understand what the jet stream is actually supposed to be doing in August. This fast-moving river of air, roughly 30,000 to 35,000 feet above the ground, follows the sun throughout the year. As the sun climbs higher in spring, the jet stream shifts poleward, and by the height of summer it typically settles somewhere near the US-Canadian border, acting like a natural boundary separating cooler northern air from the warmer air sitting to the south. That is, where it is supposed to be right now, roughly in its northernmost seasonal position, calmly separating the two air masses, the way it has, for as long as meteorologists have been tracking it. That is not where it has actually been. This summer, the jet stream has been behaving in a way meteorologists describe as structurally different, not simply hotter, but fundamentally reorganized. Climate scientists have documented that the Arctic is now warming roughly 4 times faster than the global average, a phenomenon known as Arctic amplification. Because the jet stream exists specifically due to the temperature difference between the Arctic and the mid-latitudes, a narrowing gap between those two zones slows the jet stream down and makes it wavier, more prone to bulging northward in dramatic loops rather than flowing in a relatively straight line the way it once did, a change researchers have been documenting with increasing concern over the past several summers. Here is where this gets genuinely unusual. A slower, wavier jet stream becomes far more prone to something called blocking, forming, what meteorologists call omega block patterns, named for the shape the jet stream takes when it bulges upward and holds in place, resembling the Greek letter omega. Once that shape locks in, it becomes remarkably stubborn, sometimes holding an entire region under trapped, stagnant hot air for a week or more before the pattern finally breaks down and reorganizes. Under a normal ridge, air is sinking, which compresses and warms it while clearing out clouds, producing sunnier skies and temperatures well above seasonal averages for however long that ridge happens to sit in place. Under an omega block specifically, that ridge gets flanked by 2 areas of low pressure on either side, effectively locking the entire 3-part structure together so that none of the individual pieces can easily drift away and let normal weather patterns resume. This is precisely the configuration meteorologists have been documenting again and again this summer on 2 separate continents, each time producing another round of record-breaking heat, and each time leaving forecasters watching to see exactly how many days it will take for the pattern to finally loosen its grip. If you're finding this as fascinating as I am, go ahead and hit that like button. Understanding what's actually driving this pattern is exactly why this channel exists. Now let's walk through exactly what this pattern has already produced this summer, because the sequence itself tells the story better than any single event could. Europe was hit by record-breaking heat events back in May and June, driven by an omega block, anchored over the Iberian Peninsula and France, pushing temperatures past 40 degrees Celsius and reaching as high as 45 degrees in some areas. Then a slow-moving heat dome settled over the eastern United States in early July, toppling temperature records across the region. That was followed almost immediately by another sprawling heat dome that spiked temperatures to 115 degrees Fahrenheit in Montana, an almost unthinkable reading for that part of the country. And now, this weekend, a 4th heat dome has strengthened into the most powerful one recorded anywhere on the planet at this moment, centered squarely over the American South, expected to bring days of extreme heat and dangerous humidity lasting well into early next week. Each of these individual events already made headlines on its own. A ridge of high pressure that settled over the northern Rockies in mid-July pushed numerous weather stations across Montana, Utah, and Wyoming to their highest temperatures ever recorded, since record-keeping began in those locations. Heat domes function by suppressing clouds and precipitation entirely, putting the brakes on the natural convection that would otherwise help a region cool down, which is exactly why each of these events has been able to intensify rather than simply pass through the way summer heat traditionally has, leaving communities with days rather than hours of dangerous, unrelenting heat to endure before any real relief arrives. 4 separate record-breaking blocking events on 2 different continents within roughly a single month. The cadence is exactly what has scientists using words like structural rather than simply unusual. According to researchers tracking this pattern, this is not just background warming making already hot summers slightly hotter. It reflects a genuine change in how the atmosphere itself is behaving. with the jet stream's position and waviness shifting in ways that keep producing blocking events far more frequently and far more powerfully than anything in the recent historical record. A shift that scientists say demands far more attention than treating each individual heat dome as its own separate, unconnected weather story. There is actual data confirming just how locked in this pattern has become. Researchers tracking the jet stream's wave activity found that specific resonant wave numbers, essentially particular wave patterns within the jet stream itself, were sitting at the 94th percentile for July amplitude and staying amplified for 7 out of the following 16 days in their forecast models. In plain terms, the atmosphere's waveguide has been trapping these amplified wave patterns and holding them in place for days at a stretch, exactly the kind of stalled, resonant configuration that produces the most persistent and dangerous heat domes. This kind of wave resonance is a relatively new area of active research, and it helps explain why these blocking patterns have felt so much more stubborn this year compared to past summers. Rather than simply measuring whether a ridge of high pressure exists, scientists are now tracking the underlying wave dynamics that determine whether that ridge will pass through in a couple of days or lock itself in place for a week or more. When those specific wave numbers get trapped and amplified simultaneously, the entire hemispheric pattern effectively seizes up, holding whatever weather happens to be underneath it in place far longer than the seasonal norm would predict, a dynamic that had gone largely unmeasured in this kind of detail until fairly recently. Make sure you're subscribed to this channel because we're going to keep tracking exactly how this pattern develops as we move deeper into late summer. And this current weekend's event carries an additional factor that makes it even more concerning: drought. Soil moisture across large stretches of the Great Plains and Midwest has remained below average this summer, following a drier than normal spring. While dry ground heats up significantly faster than moist ground, because instead of the sun's energy being used to evaporate water from the soil, it goes directly into raising the surface temperature instead. That means the exact regions already primed by drought are also the regions now sitting underneath the most powerful heat dome measured anywhere on the planet this year. It's just a compounding effect that pushes already extreme temperatures even higher. This drought and heat feedback loop has already played out earlier this summer in ways that offer a preview of what this weekend's event could bring. When a similar high-pressure ridge settled over the central United States back in late June, forecasters specifically pointed to below-average soil moisture across the Great Plains and Midwest as a key reason that event intensified so quickly, since dry ground amplifies whatever heat dome happens to be sitting overhead rather than buffering against it the way moist soil normally would, a pattern now repeating itself almost exactly 2 months later. There's also a piece of this puzzle connecting all the way back to the Pacific Ocean. This summer's heat domes have been supercharged by a rapidly intensifying El Niño pattern. Normally, El Niño does not meaningfully affect the jet stream or broader weather patterns until late fall or winter. But this year's event has strengthened so quickly and so significantly that it is already producing summer impacts, adding yet another layer of energy into a system that was already primed for record-breaking heat. Scientists tracking this El Niño have noted that its unusual early intensification is itself somewhat unprecedented, a pattern researchers do not typically expect to see influencing conditions this dramatically before autumn even arrives, when that early, unusually strong Pacific signal gets layered on top of an already wavier, more blocking-prone jet stream driven by Arctic amplification. The result is a summer where multiple independent atmospheric drivers are all pushing in the same direction simultaneously toward more frequent, more severe, and more persistent heat events across the entire northern hemisphere, rather than the kind of isolated, short-lived heat spells that used to define a typical summer season. So what does it actually mean that scientists say this jet stream position has no comparison? It means that when researchers go back through the historical record trying to find a summer that matches this specific pattern, 4 major blocking events across 2 continents within roughly a month, tied together by a jet stream running unusually wavy and displaced from where seasonal norms would place it, they are not finding a clean precedent. Individual heat domes have happened before. Individual omega blocks have happened before. What has not happened before, at least not with this frequency and this intensity stacked back, is this specific combination playing out across an entire hemisphere in such rapid succession. Meteorologists comparing this summer against decades of historical records have noted that even severe individual events from the past, ones still remembered as benchmark disasters in their own right, did not arrive as part of a sequence this tightly packed. A single powerful heat dome is a notable weather event. 4 of them, breaking records across 2 continents within 1 month, each one connected to the same underlying jet stream distortion, is something closer to a structural shift in how the atmosphere is currently behaving, which is exactly the distinction scientists are trying to draw as they study this pattern in real time. 1 weather station, 1 broken record, and 1 stalled ridge at a time. This is precisely why meteorologists are urging people not to treat this weekend's heat dome as simply one more hot spell to wait out, but as part of a genuinely larger pattern worth understanding. The jet stream sitting out of position this many times, this severely in a single August, is not a coincidence or a random unlucky stretch of weather. It is the visible, measurable signature of a genuinely different atmospheric regime, one where the boundary that used to reliably separate cool air from hot air keeps buckling, stalling, and locking dangerous heat directly over tens of millions of people at a time, with no clear historical comparison to tell us exactly when or how this particular pattern finally breaks. What happens next depends largely on whether this current blocking pattern behaves like the ones that preceded it earlier this summer, breaking down after roughly a week before reorganizing somewhere else, or whether it proves even more stubborn than its predecessors. Either outcome leaves meteorologists watching the same underlying signal closely, a jet stream that keeps finding new ways to stall exactly where it should be flowing freely, turning what used to be brief summer hot spells into extended, record-breaking sieges that millions of people now have to plan their entire week around, with no guarantee that this fourth event will be the last one before summer finally loosens its grip.